Hey guys, welcome to 7.8. I've split this into 3 parts. If you check on the notes, you'll see an intro part to this about relative rates of growth. And now we're going to talk about improper integrals. And there's 2 types, a type 1 and a type 2 improper integral. So today we're going to talk about the type 1 improper integrals. Take a look at a problem like this, 1 over x squared. The graph looks like this. What if I wanted to find the area from 1 out forever? Well, how would that look? Well, area is an integral, so from 1 out forever is infinity. This is what makes it improper, because it has an infinity in the answer. Now, it looks like it would be infinity, because it goes on forever, but that's not necessarily true. Type 1 improper integrals have an infinity in it. So how do we do this? Well, we replace infinity with t, integrate, and then take the limit as t goes to infinity. So we're going to integrate with t, and then take the limit as t goes to infinity. This also works going the other way. I could go from negative infinity to a number. So go from t to that number, and then the limit as t goes to negative infinity. It works either way. So let's do this problem like we said earlier. So this is really the limit as t goes to infinity from 1 to t of 1 over x squared dx. That's x to the negative 2. If you integrate that, you get negative 1 over x evaluated from 1 to t. So that tells me it's the limit as t goes to infinity of negative 1 over t minus negative 1 over 1. What's 1 over infinity, or 1 over an increasingly large number? It's 0. Minus a negative is positive 1. This thing has an answer. The answer is 1. So even though it goes to infinity, it still has a sum, a total area. If there's a finite number, then we say the integral is convergent. It converges to the number. If it's infinite, then it's divergent. It grows forever without bounds. You can also have 2 infinities, from negative infinity to positive infinity, and just treat it like 2 problems. Negative infinity to some number, I use 0, and then from some number to infinity. Just split it up. We'll try one in a second. So we did 1 over x squared a second ago. Let's try 1 over x. So that's the limit. As t goes to infinity. 1 over t, 1 over x dx. So that is the limit as t goes to infinity. What's the integral of 1 over x? It's the natural log of x from 1 to t. This is going to tell me it's the limit as t goes to infinity of the natural log of t minus the natural log of 1. But what is the natural log of infinity? It's infinity. Once you get infinity, you can stop. This answer is divergent. It does not converge. No matter what happens, once you get infinity, you can stop, because infinity doesn't work with anything else. Now be careful, 1 over infinity is 0. So 1 over x is divergent. 1 over x squared was convergent, and we'll talk more about that in chapter 8. Let's take a look at this problem. Let's split this into 2 problems. This is the limit as t goes to negative infinity, t to 0, 1 over 1 plus x squared dx, plus the limit as t goes to positive infinity, 0 to t, 1 over x squared, 1 plus x squared dx. Okay, that's the improper integral part. From now, the rest of this is basic integration. How much of this do you remember? How do I integrate 1 over 1 plus x squared? Well, you can't use u substitution because you need a 2x and you don't have that. What is the integral of 1 over 1 plus x squared? It's arctan. And those are things you've got to be able to remember for an AP test. All these little things, the memorizations. You have to know all of your integral and derivative rules. So let's plug in what we know. The limit as t goes to negative infinity. This is arctan of 0 is 0 minus arctan t plus the limit as t goes to infinity, arctan t minus 0. Arctan of 0 is 0. Well, you need to have some idea what arctangent looks like. Since tangent's graph looks like this, and has asymptotes here and here, that means that arctan looks like this. It has asymptotes here and here. Now whatever these asymptotes are, they're the same as these asymptotes. What are the asymptotes for tangent? Well, they're negative pi over 2 and positive pi over 2. So negative pi over 2 and positive pi over 2. So what's that mean? It means that this is 0 minus, if you go to negative infinity on arctan, you get negative pi over 2. Plus, if you go to positive infinity on arctan, you get pi over 2. Minus a negative is positive, pi over 2 plus pi over 2 is pi. Don't forget your trig and your trig inverses. That does it for type 1 improper integrals. The next section is type 2 improper integrals, and we're going to do them pretty much the same way. If you have any questions, come talk to me, guys. Thanks.